What up, Golden Bears? Hey, we're back with another solution set here for you. This time we are looking at page 363, getting ready for the quiz tomorrow. Page 363, this is number 17 and 19, and this was giving some people some trouble, especially during class. So wanted to make sure that we were all on the same page. So we'll look at number 17 first, and then 19, which is a real doozy. All right, number 17, we're looking for YOB. So that would be this guy right here. YOB, that one in red. So let's look at what we're given already. We're given that AB is equal to CD, which is 100. So since we have also OX is perpendicular to AB, so these are perpendicular right here. We have right angles all the way around that. You can just imagine that all the way around. And then OY is perpendicular to CD. So we have that all the way around. That means if we're perpendicular there, then we must be bisected in our minor arcs. So this would be 50, 50, 50, and this is 50 here. We're given that BD is 40, and then we'll know that AC out here is 120 if we add all that up. So if we're trying to find YOB, again, that's, I'll outline it in green right here. YOB would be this angle. Well, check it out. That's a central angle. So this is actually fairly simple. It's a central angle, which means it is this entire intersected part right here. If we draw our angle, our alligator, that's the part that it chomps, and a central angle is equal to its intercepted arc. So YOB is just 90 degrees. So pretty simple on that one. Now, where the challenge comes is on 19. So if we start redrawing back in again, the pieces that we know, let's do that. So this, again, we know is 50, 50, 50, and 50. We know that this is 40, and we know that this is 120 up here. All right, I'm going to actually see if I can make my pen a little smaller. All right, we'll see how this works. All right, so this is what we know. We also know that we have right angles here, right angle there, we have a right angle here. We also know that, that pen doesn't work very well. That's the calligraphy pen. We'll go back to the normal one. We know that we have right angles there, we have right angles all around both of those intersections. Now, we have that. Now, since these chords here, AB and CD, you notice they intercept the same measure of minor arcs, so that means they must be congruent. And since they're right angles, they must be perpendicularly bisected, and therefore those chords are congruent. And if they're congruent, then that means that they are equidistant from the center, and so that these pieces right here are also congruent, which means we have an isosceles triangle there. So that means, if you're still following me, that I have this angle that I'm drawing in red is congruent to this angle right here. Okay, we good so far? And since this is a right angle, and this is a right angle, and since they both have the same angles that are congruent on the other side, the supplementary angles must be congruent, so I'll draw these in green. So this angle right here is congruent to this angle in green. We following so far? Okay, good. Now I'm going to draw an imaginary line from B to D. Right there, B to D. Actually, I'm going to erase that because that was pretty terrible. That was not what I expected. Okay, we're erasing that B to D line. We're going back to, here's what I wanted to do. I want to draw a green line like that. Okay. So we drew this line right here from B to D. Now you'll notice that this B and D now are inscribed angles from what I just drew. Inscribed on the circle. So let's draw these in blue. Check this out. B, if it's an inscribed angle, what are the pieces? Well, angle B intercepts arcs that are of length. Let's see, 120 plus 50 plus 50. So that would be 120 right here, and then 50 plus 50, 100. So angle B is 220, and since it's inscribed, and so actually it's 1/2 times all of that. So it's this divided by 2, so angle B equals 110. Well, if you notice, angle D intercepts the same exact measures, just that the 100 is on this side. So angle D equals, or is congruent to angle B, and they are both 110. Now, here's where it gets a little bit more crazy, so see if you can follow me. I'm going to outline this in yellow. Right here, we have a quadrilateral. And it's not just any quadrilateral. We have congruent pieces top and bottom, so it is actually an isosceles trapezoid, where D and B are equal, and then the other two angles are congruent. We proved that earlier because they were the complementary angles to the little angles in this triangle out here. So if you can follow all of that, we now know that these two angles are congruent to each other, and we know that they must be supplementary to the larger angles B and D that we just found, because we have an isosceles trapezoid. And also they must be supplementary or congruent to each other. Never mind. All right, so we have enough information, so let's solve this here because we are looking for yxb. So if this diagram wasn't messy enough yet, we now are looking for yxb right here in red. This guy right here, yxb, so measure of angle yxb must equal 110 or 180 minus 110, and that will equal 70 degrees. And there may be a more simple way to do that. If you figure it out, please let us know, because we are fallible human beings too, just like all of you. All right, that looks starting to look like a work of art there, so we're going to leave it, and hopefully that helped you guys. We'll see you soon.